Good morning, dear students. Today we are starting Calculus 2 with 8.2. Before we got many revision, now today I'm going to mention something new for you. Maybe you heard also about that one in high school. I don't know if you cover the integral in the high school. Also, you have that one. Otherwise, here we are. This is the first time you heard about it. And we are going to talk about this method, these techniques, step by step. So first of all, we have the name is integration by part, or sometimes called UDV. It's called UDV, not UDU. UDV means that if you have an integral and there's multiplication between two functions like that, x e to power x dx. This is the simplest example in the UDV. So you see that we can solve x dx separately. We say is x squared over 2. And also we can solve e to power x dx, which we say is equal itself plus c. But when they are together, we cannot. And you know, we cannot separate the integral over what? Over multiplication. We mentioned that. It will be kafir, it will be taboo. That's why we cannot do anything. So how we solve such example like that? How we deal with that one? So we have a technique for that one, which is called integration by parts, because we make the part by part. So we call this integral together. We say ex x dx. One of them like u, one of them like dv. So we have two functions, f and g. One of them called u, one of them together is called dv or g. Understood? So this is the first thing that we should do. We should separate them, recognize them. Then later I'll give you such clue about how to recognize them. Don't worry. So again, we have x e to power x dx. Now I say I have u dv. Now I say let u be x and dv be what? E to power x dx. This is the first step of solution, to recognize them and let them. So now we have a, suppose u be x and dv be e to power x. Then directly find du for the first step. So du is equal to what? Here in this example, derivative of that side equal to derivative of the other side, right side. So I will get dx. And directly take integral of both sides dv ex dx to get v, because we need u du, v dv, all of them. So in that side I say dv, integral of dv, it will be v. Understood? And integral of ex, it will be itself, ex plus c. But here I am not going to write down c, because later we have another c, so we collect all of them, or we add all of them, and we put them as a c. So the second step, after letting x and u and dv, we are going to take a derivative for u, integral for dv. Okay, so this is the second step. Now I say u dv is equal to what? Here's the rule. The rule say that you will get u dot v minus v du. That's why we need u v du. Means that our integral is that we had, it will be u. Where's u is equal to what? u v minus of the rule v, where's v? Again x du. Here's du. Now you can see the integral, the first integral. It was hard and separable. We couldn't make anything. But now I got what? Easy or direct or formula or anything integrals. And usually to measure that you are in the good way or not, you did well or not, this integral should be easier than 1. Of course, should be easier than. Later, I'll tell you how and why. So the result of that integral, as you know, is equal to x e to power x minus e to power x plus c. That's your answer for your integral. I recall as I. So here we are. The first important thing to distinguish between u dv. The second is what? You have uv minus v du. That's all we need. Understood? That's the rule. I'm going to look at here. This formula is better for you. Forget about that. The same. I'm going to solve x cosine of x. And we have note. Such note. If integral v du is harder or is harder than I, when I say I mean the original integral that we have, means that your let is wrong, is not correct. Change it, you will get right selection. What do you mean by that? We say that if I have I, which is equal to uv minus v du. If that one is easy, it's simple, easy, you are right. If it's the same level, we have something. If it's harder, you are wrong. And when I say if it's the same level, we have something, later I'll tell you. We have reordering or I don't know, some name we have. So for now, I'm going to solve the second example for you. We have x cosine x dx. How many functions do we have? 2 functions, right? One of them polynomial, simple polynomial, linear polynomial, and the other is trigonometric function. Am I right? Okay. It's better to make your decision which one is u, which one is dv. And of course, because we need to reduce the exponent, we need to reduce exponent. For example, if this is an x squared, x to power 3, we need to make the x to power 2. We need to make 2x. So that's why it's better to choose x as a u if you have x, because later you will have ex cosine x will change. So here we are. Yalla, let u, first step, let u be x and dv be what? Be cosine of x dx. Second step, what shall we do? Second step, yeah, from here du is equal to dx from here, integral of here is equal to integral of here. So integral of dv, v, integral of cosine, sine of x. Understood? The third step, what we have, we say our I is equal to uv minus v du. Am I right? Okay, uv minus v du. So the integral will be, where's u, where's v, where's minus, where's v, where is du, dx. Understood? Du equal to dx. So now, before going to the fourth step to solve, I'm going to compare that one. Look here, that integral with what? With I. Tell me, is easier or not? It's easier. You can solve it directly, right? But how about x cosine x? No, we cannot. We don't know. There's no box d box. There is no formula, right? There is no anything, no inverse. So that's why I say I'm in the right way. Our selection is good. So I say is equal to x sine x plus cosine x plus c. Why plus? Because I know the derivative, the integral of sine minus cosine. So we multiply by minus, we got that. So I'm going to solve that example again by mistake to understand what I mean by that one, by that chart, what I mean by that chart. Okay. So I'm going to solve the same example, I equal to x cosine x dx. I say let u be cosine x, dv be what? X dx. Am I right? The same. Maybe in your during the exam you mix them. So how we check also? How I know I am in the good way or not? I'm going to solve it or not. The second step, yalla, derivative of u, right? So du will be minus sine x dx. How about integral of here? V will be integral of here, both sides. V will be what? Yalla. They? X squared over 2, right? So it's time to say I equal uv minus v du. So I say uv minus, here's u, here's v, minus v du. Look at here. Compare that one with your example. X cosine of x. Yalla. Compare that one with that one. Easier or harder? Why? Why harder? In here we have polynomial of linear, right? Degree 1. With trigonometric functions. How about here? We have degree 2. So we make more complicated, right? So it's harder than the previous one. So that's why I say my let is not right. I'm on the wrong way. Now you got the idea, right? Understood? Understood, dear? Good. So that's why we cannot solve like that. It's unsolvable. If we cannot solve easier one. So of course the hardest one is not ready for solving. So I'm going to another example. I'm going to solve that one. So like a special case. ln of x. Example 2. Ln of x dx. Before I told you, when you have two functions, so write that note for you on your lecture note. When you have two functions, we are going to use, right, u dv. But here we have one function, right? So where is the other one? Where is the other one? No. We would like to be easier, not make a problem. We need to solve the problem. So there's one function as if, for example, if g is what, dv is what, it's like that. So u dv. Now I say is what? I say let u be ln of x. Why we cannot solve ln of x dx? Why we cannot? Before I say yes. There's no what? No, forget about u du. Think about it. You are in the exam and you don't know which method we should use. Tell me about the direct solution of u du, ln of x. Yes. No, you say something, but I make them. Yes. No, don't think about u dv. Before this lecture, why we couldn't solve that one? Do you have a direct? That's my question. Do you have a direct, any direct integral? Of course, no. Check your 8.1 table or anything. We have that one. You're right. We have that one, but we don't have that one. We don't have it. That's why we are going to use another method, another thing. There is no formula. There is no, what do you say? Nothing to solve it. That's why I'm going to solve, yalla. U be what? Ln of x. dv be what? Just dx, okay? Okay, now, do not forget about this example. First example in 8.8, improper integral, we have that one with such thing like that. So careful, if you don't know how to solve that one later, we need to learn, limit then that idea. So please try to learn here to get the idea. So du is equal to what? Hello? Derivative of ln is equal to what? 1 over x, you are right, 1 over x. Thank you. And how about dv? If I have dv equal to that one, if dv is equal to dx, v equal to what? Of course, x, right? Now it's time to solve ln of x dx. We say is equal to what? uv, I bring it to the other side, minus v du. Check yourself. You can see that one easier than the previous one or not? Easier. That's why I say I'm in the right. Yeah. So ln of x then equal to what? I equal to x ln of x minus x plus c. Oh, so it's solved. None of the previous methods, none of the formula can solve ln for me. And there's a special thing, what? Instead of two functions, I have just only, we have only one function. That's why. Understood, dear? So today, all examples around u du. Now, you have another example. Look, the type of example, it was like that. X e to power x. We saw something like that, right? X cosine of x. So it means that x with the exponential, polynomial with exponential, polynomial with what? With trigonometric function. Now another example that I have, and do not forget about ln. We have a just ln, another example. Now I have another example. I can see x square e to power x dx, the same. We have what? We have polynomial, am I right? With exponential. So it's better to let u to be what? U be what? X square. Why? Because we choose something after the derivative, the exponent, the degree reduced. Understood? We are going to choose something that after the derivative we get reduced. Understood? Say, look, from the square to linear. That's why. Okay. How about du? Sorry, dv. So v will be what? Understood. Now I say I equal. Do not forget about I. I is that one. I equal to what? uv a minus v du. Am I right? Checked. That one is easier or not? Are you sure about that one? Why it's easier? So you are right. What else? Exactly. We have an x ex. In the previous we had what? X squared. So it means that you are good. So how we solve x ex? How we solve that one? Like that? You mean like that? Another I. So you mean another u du, right? V du. Okay. So again, it was the first example. You forget about it. The first example, you solve that one. Look. Hello, good morning. Okay, so we solved that one before, right? I got what? The result will be what? Ex, x ex minus x. So I'm not going to solve again. So I'm going to put the result here. Thank you. Another I, another. So you say is equal to, right? It was something like that. So again, I say I equal to x squared e to power x. Or you can call that one double I and solve again. For example, in exam, if I bring something like that, so you need 2 times u dv, right? The first you are right, the second you should solve it. So that's all we have. You can see here that one directly, and you get the result. X squared ex minus 2 and plus 2 and go on. Do you have any question? I don't know. There was a method here. I don't know if mentioned in this book, in this version of book. Let me see. No. So we have tabular. We have tabular. We call tabular. tabular method, for example, if I have x to power 3 e to power x dx, how many udv I need? 3 times, right? Understood. So how we solve that one? Easier that one. So I'm going to use the f and I'm going to use g. That one is not in your book. Take care. So we put something here with the derivative in the last step is equal to 0. Understood? And I'm going to put something here, so that one for derivative and that one for integral, that we can integral them. You got it? So, okay. Derivative of e to power x equal to what? Derivative of here? 3x squared, right? How about integral of here? Okay. Derivative of here? How about integral of ex? Again, ex. Derivative of here? How about integral of here? Okay. Derivative of 6? How about the integral of here? 0, right? You got the idea? Now, I'm going to use the cross from here to there, to there, to there. You got it? And I'm going to put a sign. I say the sign here is positive, negative, positive. So what do you mean by that one? It means that if I have x to power 3 e to power x dx, the result will be 3x squared e to power x minus 6x e to power x plus 6 e to power x plus c. It was easier, right? So the same thing is true. The same thing is for the x part. Understood? So I think in your exercise, you have such example like that. Let me check the exercises. Give me 1 second. No, 1 second. Need more. This is in your exercise. It was in the another section, another version. It's actually here, not here. No, we don't have it. Yes, here we are. It's 2, 3 the same. So how we solve that one? Let me change it to 2 for you. The same. X to power 3 is harder. So how you solve that one? At least we need 2 UDV. So I'm going to check, write F, write G, and I say x squared, and I say sine of x. Now, derivative of 2x, derivative of x, derivative of 0. Integral of here, integral of here, integral of here. So positive, negative, positive. So I will get what? I say I equal to x squared minus cosine of x, okay, plus 2x sine x plus 2 cosine x plus c. Understood? Instead of taking 2 times UDV, it's better to use that one. But do not forget that one. Here should be 0. So it means that if you have a polynomial with something and the polynomial has higher degree, you can use it. During the exam, I'm going to bring that one. So if you solve that one by the classic UDV, you know, you need many times, right? So time consuming. That's why you need to use the tabular. But I don't say use the tabular, up to you. Okay? You feel free, whatever you like, but that one is easier and faster and more accurate. Here we are. So okay. Another example. We have I equal to what? Ex cosine of x dx, which is called okay. So how we solve that one? The previous examples, all that we have, we at least we have polynomial x to power something, right? Or just we have a limit. Otherwise, we have x square x ex, right? We have a x with the ex, we have a x with the trigonometric functions or sine or cosine, the 2 power 3 to power 4, or all these ideas was about that one. How now today, or that example, sorry, is what? Is we have exponential with a trigonometric function. So how we solve that one? Of course, one of your exercise is ex sine of x. So how we solve them? How we deal with that situation? Yalla, let you have two functions, right? So, and you cannot use the tabular here because none of them is equal to 0, the derivative of none of them. So let you, okay, right? Okay. So second step, understood. V is equal to, now I say I equal to uv minus v du. Am I right? So it's time to check yourself. So here, double I with I, easier? No. Harder? The same level, right? So you remember we have a same level. So here we have the same level. Why is that we say the same level? Because we have exponential trigonometric, the same exponential trigonometric function. So how we solve that one? We stuck here, right? So look at the idea, how we solve it. We stop here. We recall that one as double I. I'm going to solve double I. Okay. So I say double I. I'm going to the next page because later I'll bring that result to there. So I say double I is equal to e to power x sine of x dx. Again, let u be, okay, dv, then du will be what? Dx. How about v? Right? So I say double I equal to uv minus v du. Am I right? Do you have any problem with it? Do you have any problem with that one? So I'm going to put this result in that green box to its place. It was minus ex cosine x minus ex cosine x, okay, plus ex cosine x dx. Do you have any problem? Do you have any comment? Did you understand what did I do till now? Hello? Clear? Good. So I just put everything in its place, nothing else. So double I equal to ex sine x minus that one. So I'm going to multiply this minus ex sine, I say I equal to sine of x minus multiply minus plus ex cosine of x minus ex cosine x dx. Am I right? And what's that? Exactly, opposite of the first. So I got what? I equal to ex sine x ex cosine x minus I. Am I right? So we solve the example and we got the same. You solve the problem, we got the same problem. So how you solve that one? I'm going to bring that one to other side. Look. So I will get what? I plus I, it's equal to 2i. 2i equal to what? Ex sine x, right? And I equal to what? Solved, right? So we reduced again. That's called reduce. If I have the same level, I should go to solve by reduced way. What do you mean by reduced? From I will get the same example, the same problem by 2 times solving. So I'm going to repeat it again for you. At the beginning, we have that one. Then later we solve and we go the same level. So if we are in the same level, I have a note about reducing. Reduced, again, we use them. So I will be something, and this one I should solve it again. So I solved that one, I got this. During the solution, you should get minus. In case you make a mistake from the derivative, that one is addition, means that wrong, because you get 0 equal to that one. It's not right. So that's why you need to get negative I, negative. Understood what I say? You should get negative I, because later we will bring it to the left side and I will get 2i and I will get the result after division. Any question about that example? So you need to solve that one carefully. We need to integrate them, and again you get the same. Example number 5 is not included. So and look at that example. E to power x sine of x is a homework. I think it should be homework, right? So that one you cannot solve directly. You use the I and double I. Do not forget about that. So the last things here, how to solve that example if I have boundaries. So if we have definite integral from 0 to 4, it's easy, the same. Example number 6. From 0 to 4, we have x e to power minus x dx. We can solve that one by 1 mu dv. It's easy. So I'm going to use that one. Or you can use tabular. Up to you. Whatever you like. So I have a 1, I have 0, right? Okay, well, I have that one. Somebody. Yeah, just kindly, general. Thank you. So derivative of here. We have x e to power minus x, sorry, f and g, first of all. We have f for derivative, g for integral. So let be x, let be minus e to power x. So derivative of x, 1, integral of ex, minus, right? Derivative of here, 0, derivative of here, ex. Now we have positive, negative. So the result will be what? The result of this integral from 0 to 4, x dx will be minus x e to power minus x minus e to power x from 0 to 4. Instead of writing 0, we are going to write that like that. Sorry. Here's your integral. So it will be what? It will be 4 e to power minus 4 minus e to power 4. And minus 0 e to power 0 minus e to power 0. So I will get what? Minus 4 minus 1 minus 5 e to power minus 4 minus 1. And I don't need that one. So that's the first method. The second method for solving such example like that is the classical one. You say u, let u be x, then du will be dx, right? And dv be e to power minus x dx, then v will be minus e to power minus x. So uv is equal to minus v du. And you know, we have from 0 to 4. That's why you have from 0 to 4. That was the difference. Okay, the previous is the same. So you can solve that one. I will get minus x e to power minus x from 0 to 4. And that one derivative here exists. I will get e to power minus x from 0 to 4 and substitute, you get the same result. Do you have any question? Dears? Okay. So we're going to take a rest. Oh.